Circle the equation of a straight line that is parallel to the line 3y equals 2x plus 6. Okay, remember with straight lines we've got this y equals mx plus c, yeah? Remember that concept? And c, if you recall, represents where the line, right, and this is a line, as I said, cuts the y-axis, okay? So we call it the y-intercept, don't we? Where it intercepts the y-axis. This value we're adding on here. The m represents the gradient, okay? How the slope of the curve, basically, how steep it is, okay? So when we're talking about parallel refers to direction, okay? So if it's parallel, it's going to have the same direction, isn't it? Okay, if they're going in the same direction, they've got the same steepness, yeah? They could be both vertical, they could be both horizontal, or they have the same slant, right? Exactly the same rise or the same fall. Now, we would refer then to the m value, okay? The gradient would have to be identical, okay? But you have to be careful. You see the value in front of the x here is 2, okay? Now, if you look at all of these, there's a 2 in front of the x there, there's a 2 in front of the x there. So you might be thinking, well, one of them is right, one of them's wrong, I don't know, okay? But then you need to sort of look at the setup of it, right? Remember now, the straight line is y equals mx plus c. But if you look here, right, we haven't got y equals mx plus c. We've got 3y, right? There's a number in front of the y, and the same here. There's a 3y. So what I'll do with my original one, okay, I will get this so that it's y equals, okay? And for it to be y equals, you need to take this 3 over the other side. And of course, because we times in by 3 here, right? When we take it over, we divide by 3, yeah? So we'd have, for my original, we'll have y equals, so I take the 3 over and divide, it'll be 2x divided by 3, yeah? And of course the 6 needs to divide by 3 as well, okay? So you take the 3 over and divide everything by 3. So I get 2/3 x plus, this will become 2, won't it? Now I'm not worried about this bit here, I'm more concerned about this here, okay? So my m value for the line is equal to 2/3. Now, which of these here will give me 2/3 when I get it in the form y equals? Well, if you look at the first one, right, if you take that 3 over and divide, you will get 2/3, won't you? Okay, let me do it up here where I've got some room. You'd have y equals 2x divided by 3, and then of course the 7 would need to divide by 3 as well. You take the 3 over. Now don't worry about that, that's not important. That's just saying where it cuts the y-axis. But the gradient is 2/3. It's exactly the same as the gradient of my line here. It's just got the same slope. This is the one I circle. If you did the same for the others, you'd have a different gradient. B then says circle the equation of a straight line that is perpendicular to this line, right? Now this is lovely. It's in the form that we want, y equals mx plus c. But again, right, perpendicular is referring to the direction of the lines. Okay, so perpendicular, I mean, if I do a little sketch, what I mean by perpendicular, of course, is at right angles. So one line could be like going like this, okay? That could be your line here, right? This could be y equals 5x minus 3, okay? The other line then would be perpendicular to it, okay? So perpendicular would be like this, so at right angles, okay? That's what we mean. So it crosses at right angles. So it's referring to direction, isn't it, these lines? So we've got to focus on the gradient. Now the gradient here is 5, okay? Gradient here is 5. So what's the gradient got to be like of the other one? Well, there's a simple thing you can do, right, to work out what it should be. And quite simply, if the line is perpendicular, when you times the gradients together, right, it should equal -1. Now, let's just take this one for instance here. Let's compare these, right? And if I times that gradient by that, do I get -1? 5 times -5, well no, I get -25. So it can't be that one, right? So you just got to go through each one. Now, if you choose that one there, if you look at that one, right, that is 1 over 5, or -1 over 5. So if I take my gradient there, 5, and times by this here, which is a fifth, -1/5, sorry. If I do that, 5 times -1/5, you do get -1. So we wanted to times to give -1, so it's got to be that one there.